All right, guys. So these are the notes, the audio version of the notes for learning goal B. So this is the second learning goal. We went over this in class on September 29th and the 1st of October. So given a scientific problem, I will be able to create an authentic, which just means original, your own, testable question and hypothesis. That is the goal of this learning goal. So creating a testable question. A testable question is a question in which you can measure the results, okay? So this is something, not just any question. You could say, hey, what's going on? That's a question, but it's not testable. You could also say, we want to know if a roundabout is faster than a four-way stop. That's a question. It's not testable. For it to be a testable question, it needs to be written as how does blank affect blank? Because then in that question, you are stating exactly what you're going to test for your experiment. So for example, how does the type of intersection affect the number of cars that get through? How does the brand of coffee affect a person's energy level, right? Any way that you do it, you fill in the blank with what's being tested. So here's an example. How does water affect the growth of a plant? Water is what we're going to be changing. The scientist is going to change. And the growth of the plant is what the scientist is going to measure. Now let's look at this plant problem. Dalton got 2 plants for his birthday. He put one on the windowsill and one on the coffee table. The one on the coffee table only received sunlight for a couple hours a day. The one on the windowsill was exposed to sun all day long. The one on the windowsill died, which is wild. Dalton's probably like, what? Plants need sun. Some plants don't need that much sun. So he might say, how does the amount of sunlight affect the growth of a plant, right? Here's another problem. A puzzle maker just made a new puzzle for children, but he doesn't know if he should sell it to 8-year-olds or 10-year-olds. The puzzle should take around 20 minutes to finish. So what can he do to test which age group? He might say, how does the age of a child affect the time it takes to complete a puzzle? Because that's what he's looking for, time. So he's measuring time here. Now we need to talk about a hypothesis. Once you have a testable question, you need to write a hypothesis. A hypothesis is a fancy guess. It's a prediction for the outcome of the experiment. It's always written as if, then, because. So you can't just say, I think the four-way stop is going to be faster. You need to say, if the intersection is a four-way stop, then more cars will get through because, I don't know what the because would be there, because they're more efficient. And your because can be your guess of why that's a good hypothesis. For example, if the water amount decreases, then the lifespan of the plant will decrease because plants need water to survive. Looking at this testable question, how does sunlight affect the lifespan of a plant? A good hypothesis might be if a plant does not receive enough sunlight, then it will die at a faster rate because plants need sunlight to survive. The testable question here, how does age affect the time it takes to complete a puzzle? Your hypothesis could be if the child is older, then it will take them a shorter amount of time to complete the puzzle because our brains are more developed as we get older. It's a good because, right? And that's really it. I can't go back. But those are all your notes.